Thank you. Thank you so much, ladies and gentlemen. Yes, I think a few minutes ago I talked about designs of pier section and pier cup using general section design and the RC component of the model. Now I'm going to continue with talk about steel truss bridge or steel truss bridges. Last time I posted something on steel truss bridge, talked about the different types, and if you look at this here, this picture is a Warren type with a bit modified. Doesn't have the vertical members. This bridge is somewhere in West Pokot in Kenya. The span is about 70 meters, and if you look at it, this is a modified. It is finished. It is operational. Of course, with that, what I did, I modified to see the benefits of the redundant members. Of course, today the world is moving away from an economic design to conservative, because we have realized that when the bridge has aged or as is nearing its lifespan and you need to retrofit, because of that very economic design with highly optimized, retrofitting become a problem. And if there's problem with any of the structural member, the whole bridge always get a bit of compromised. So there is need now to move towards introduction of redundancy in terms of members. So now if you look at this Warren type, with today's perception and looking at the future rehabilitation, inspection, replacement of other members that could be damaged, use of vertical members would make sense, because that would improve on it would enhance the capacity, whereby if I remove one, I can work on this member and then the strut ties without the vertical one, and you're able to improve on their functionality. The use of peer support, or not peer support, the use of single span in a way might also be a bit questionable, because if one of these support gets a problem, definitely we run into a bit of panic, and we can easily lose this iconic investment. So there is need now to look at that. Also, the use of climate change adaptable structure, we need to improve in terms of you see this flow of water here seem to move with stone, and very soon, after maybe 5 years, you will find this area is silted and basically near to about 1.5 meter on it, and this is not a very good design. So these are things that engineers need to begin thinking about: climate change adaptable structures, robustness, and the issue of redundant members. Very, very, very important. So what I did, I came up with, which is not outside the norms and the practice. This is the normal traditional Warren type with vertical members, while this one is the Warren type improved version without the vertical members. But because of this, and we were told this was also having pile support, so we also model with piles. This is more reliable, and we're ensuring that this pile support goes up all the way to the farm rock. This is a typical cross section. This is a perspective, and then this is the plan. This is the drawing of the bridge. This is a section. This is the camber. Definitely, we will demonstrate in the model. You have this camber. This camber is for dead load. So when you do this properly, of course, construction may differ from design, because you need some temporary support in here to launch and assemble all this. Then after talking properly, then when you release, then it comes now that the deflection due to dead load will be taken care of, and then anything further than that will be for other loads like live load and other things. So this is basically a typical tradition of a topographical survey of site. This is a typical one, not specific to this bridge. But an engineer should be aware of that. Without this, then become a problem. We will not know the topology of the site. This is the geotechnical parameter, the strata. You can see here the depth goes up to about 10. This is also a typical one. And then these are the SPT values. Then also you're going to have, and this is men in action. They're doing the investigation. Okay, so this basically, of course, this is very important. I think I know it was for this is basically for knowledge sharing demonstration. This was from 2017. I think this firm did the client, I think, was UNRWA, and then the consultant was Doha. I think this is for the Kampala Busekon PJ Expressway. So basically it's a sample basically for demonstration to my student what they need to do, because normally they cannot see what happened. This is real time, so you can see these guys are doing real work here. Very well done. They understand this, and then they advise you, the designer, on how to do this. How we start looking at what they call the different deep foundation, whether it's going to have end bearing or it's going to have friction type and the rest of it. So the different layers have different factors that you consider, which you use for the design. So this one is very important, and then this information also is key. Then hydrological information. This is now where you have the bearing. This is another site. You have the depth. These are different borehole, and then sometimes the depth goes more, even up to 30, until you get the what? You get a reliable bearing capacity. Here, I think within 4 meters they were getting good bearing capacity. That's why the SPT values are higher. So basically, this is more of, you may find this is more, it's suitable for part foundation. While this one, if you look at it going up to 10 with this kind of SPT values of 19, 13, 19, definitely this cannot be for part foundation. This definitely going for pile. So that is that. What do you need to have? What knowledge area do you need to have to make sure you don't miss certain things? The knowledge areas to guide you in modeling is about expansion joints. How is it going to be? Think about the temperature, the span, the linear expansivity of steel. We are dealing with the steel bridge. Make sure issues to do with break force, the earthquake tremor, the vertical loads effect. All these have implication, have effect on the horizontal movement, which may add because if there's no loading, there's a bit of, and it is cold, there's contraction, and when you have the heat, then there is expansion. So that's how the temperature comes in. But for tractive earthquake, that is a load dependent. Still, you can also look at it and make sure you have an adequate gap or expansion joint that will not compromise on the functionality of the bridge over the years designed for. Connections are also very important. Normally we do the design, but when it comes to connection, I think unfortunately Midas does not design connection. You model it, then you need another software like Ideas Statica. I don't have a license for that, and so I cannot use it, but we have license for robot structure. It does design of connections, that one, so you need to have that. So sometimes you need 2 or 3 softwares. One will help you for modeling, one will help you with design, another one help you for connections. So basically you need to have that. And when fatigue is coming, normally we must be mindful of fatigue. So these connections we have are the stress risers, especially the defective welds, balls and plates. Normally we have to be careful with cracks propagation, cracks initiation and propagation that tend to compromise on the functionality of structural steel. The issue of elastomeric, that is of bearing types. Bearings are subject to loads and other things. These bearings will not be exposed to oil and chemical. They get, and also then also muddy soil and the rest of it. If you don't take care of this bearing, then definitely we shall always run into a bit of confusion when they are not functioning very well. So you start getting into an anomaly or anomalies during the use. On the modeling, they normally do elastic spring with associated stiffness of respective bearings. So the stiffness is the stiffness of this bearing you need to know so that you are able to model. What about operational maintenance factor to capture at the design stage and implemented during construction? This is access for inspection. Normally we have to do, I think I'm going to get time and share with you how some of these access are very important. Like if you have a busy road, you cannot go and put a ladder and stop the traffic, then start climbing to inspect the bridge surface. Normally you have access from the deck top, then you come, they can have a ladder along the pier head and then abutment head also you have. So normally that access from top, they tend to be more safe and user friendly. And also provision for replacement of bearings, expansion joints, and some members are also very important. We need to think about. So normally for bearings, they have to make sure you have adequate bearing self, both for the pier and also for abutment, whereby you are able to put the jacking. Even the design of these girders, you make sure at the design stage you have taken care of them. Some extra reinforcement and attention that need to be done so that during replacement the guidance are very straightforward. So that is very important. So basically this is brief about structural steel. Definitely there are very many types of we have the Howe, you have the Pratt system, you have the configuration, you have this Warren type and others. And so all you need is to be a bit careful, follow, and then what I've learned from structural steel is or steel bridges is the issue to do with connections. The connections which are at the level which has frequent exposure to water, wet and dry condition. Normally those connections which are exposed at that level tend to corrode earlier than connections that are at height. So there is need to think twice on how do we ensure that whenever the surface is exposed to water, and that water quickly drains away and the place remains as dry as possible. Because if we can keep the surface dry, we can keep the steel members dry, ladies and gentlemen, you'll never be worried about corrosion. You have three factors. You have that material to corrode, you need water, and you need air. So all you need is to cut off either air or cut off water. You will never have corrosion taking place. So recently I've seen there are looming disasters in some of these areas that is not easy and not safe to mention, because the footbridges that are being used by very many people moving in the city and in other places for their searching for health and other things, all the bottom plates and balls have corroded. All we need is to have a bit of strike, and there is a bit of crop loading, and many things will be happening. So I think I would, using this platform, advise institutions having footbridges to quickly have an inspection, and especially for the stratified connections at the walkway level where they have concrete. I think all these plates have given way, and therefore they are now overstressed. What is happening is the arching effect. The collections of the different members are the one now carrying the human loads and whatever load which is there. Now one day if there's a crowd and people are striking because of maybe money, pay and the rest of it, and people gather on those footbridges, we are not going to have a better story. So I think all the institutions with footbridges, please take it seriously. Try to engage the estate managers, estate engineers to quickly look at your footbridges, especially the structural members at the bottom level where they are connected using plates. The plates have given ways, and so it is important that you'll have a look at. It's very simple. How many institutions have footbridges in Uganda and in Kampala here? Please have a look at it and make sure you do something. It is not alarming, of course, but it is not also good for, if you're a designer, look at it, and then you see that what need to be done, what is designed is now has been corroded and members have failed, especially the plates connecting. That means the connections are no longer working, and if the connections are no longer working, it means there's now an imbalance in load distribution. Some members are being overloaded because the plates that would be helping to help certain members to distribute load are no longer now operational. They have been compromised because of corrosion. So please let us have that. I know it is not very difficult. There are many competent consultants in town here, and also contractors that can retrofit some of the things as early as possible. So I think that is what needs to be done. Thank you so much. Okay, good.